This slide is going to be detention time multi-step math questions, just guided with formulas and answers. Preface: I claim no ownership to any of the questions or material presented in this video, as everything I found is sourced off the open internet. In the following slides, I have, to the best of my knowledge, presented the proper formulas and correct answers to these questions. This is a study guide for me. It's helping me with preparing for my tests. If it helps you too, that's great. The state of Florida prevents you with a conversion table formula sheet for when you take your tests. I don't know about your state, and if they do, you should familiarize yourself with it while practicing math questions. So for this one, we have page 1 of 8. And this has the volume formulas at the bottom. This is page 3 of 8, and it has the formula for detention time. I will have these at the bottom of each slide. Calculate the detention time in hours for the following portion of a treatment plant. 5 flocculation basins, each 50.1 feet by 18 feet with an average water depth of 11.5 feet. A sedimentation basin that is 322 feet long, 75 feet wide, and has an average water depth of 10 feet. The flow through these basins is 15.6 million gallons a day. First, we need to find our known and unknowns. So what you know is you have 5 flocculation basins at 50.1 by 18 by 11.5 feet, a sedimentation basin at 322 by 75 by 10 feet, and a flow of 15.6 million gallons a day. What is the unknown? The detention time in hours. To find detention time, you do the tank volume in gallons divided by the flow rate. First, let's find the volume for our total basins altogether. So your flocculation basins, 50.1 feet by 18 feet by 11.5 feet times 5 flocculation basins. Sedimentation basin volume, 322 feet by 75 feet by 10 feet. Do the math on those. You get the flock basin of 51,853.5 cubic feet and the sedimentation basin volume of 241,500 cubic feet. So you're going to add the two total amounts together to get the total volume from the 5 flock basins and the sedimentation basin. Gives you a total volume of 293,353.5 cubic feet. If you've already noticed, the formula for detention time is in gallons, so we must convert the cubic feet to gallons. So we take the total volume, 293,353.5 cubic feet, times 7.48 gallons per cubic foot. Cubic feet will cancel out. Your total volume is 2,194,284.18 gallons. Alright, so detention time, volume in gallons divided by flow rate gallons per day, because that's how the formula is set up. So we're going to put the total volume on top. Right now our million gallons a day, we're going to convert that to million gallons. So 15.6 million gallons a day times a million. You get 15,600,000 gallons per day. Do the division, you get 0.141 days. Our answer is looking for detention time in hours. So there are 24 hours in a day, so 24 times 0.141. Come up with the answer, 3.384 hours. So with this formula, we can change the detention time formula to uh, gallons per hour if that's the answer you're looking for. So for that, we would have taken 15.6 million gallons a day times a million divided by 24 hours. That would have given us an hourly flow rate of 650,000 gallons an hour. And your answer would have still come out to 3.38 hours, just a little bit of rounding. Question number 2. Find the detention time in hours for a clarifier that has a diameter of 160 feet, a water depth of 10.25 feet, and a flow rate of 3.86 million gallons a day. Again, find your known and your unknowns. So we have our diameter of 160 feet, a depth of 10.25 feet, and a flow of 3.86 million gallons a day. We're looking for the detention time in hours. First, we must find the volume. Volume for a spherical vessel with diameter given is 0.785 times diameter squared times the height. Plugging in the information we have, 0.785 times 160 foot squared times 10.25 feet gives you 205,984 cubic feet. Again, we're looking for gallons. There's 7.48 gallons per cubic foot. Multiply those together, and you get an answer of 1,540,760 gallons. Now we need to convert our 3.86 million gallons a day to gallons per hour. So 3.86 million gallons a day times a million times 1 day is 24 hours. So you divide by the 24 hours. You get 160,833.34 gallons per hour. You're going to divide that into the 1,540,760 gallons. You get a detention time of 9.58 hours. Question number 3. Calculate the detention time in hours for the portion of a treatment plant with the following characteristics. 5 flocculation basins, each 62.4 by 18.1, with an average water depth of 12.3 feet. A sedimentation basin that is 298.5 foot long, 83.2 foot wide, and has an average depth of 10.5 foot. The flow is 20.9 million gallons a day. Again, pull out your knowns and unknowns, your 5 flock basins and its dimensions, your sedimentation basin and its dimensions, and your flow of 20.9 million gallons a day. What is unknown is your detention time. These are rectangle basins. So this is the formula we're going to use. Length times width times height. And I've gone ahead and added the 7.48 gallons per cubic foot just to get this all done in one step. So plug in your numbers. For your flock basin, 62.4 feet by 18 feet by 12.3 feet by 7.48 gallons to go ahead and get gallons from your cubic feet times 5 basins. For your sedimentation basin, it's 298.5 feet times 83.2 feet times 10.5 feet. And again, we added in the 7.48 gallons into the equation to convert it to cubic feet. So we're just doing it all in one step. Makes it a little bit easier. So you got your totals in gallons now. We're going to add those together. You got the flock basin of 519,565 gallons, sedimentation basin of 1,950,557 gallons. Add them together. 2,470,122 gallons. It's going to go on the top of our detention time formula. Looking for hours. So we're going to convert 20.9 million gallons a day times a million times 1 day in 24 hours. So you divide by 24 to get your gallons an hour. 870,833 gallons an hour. Divide that into the 2,470,122 gallons. You're left with a detention time of 2.84 hours. Question number 4. Calculate the detention time in hours for a water treatment plant with the following characteristics. 5 evacuation basins, each 48 feet by 20.3 feet, the water depth of 11.8 feet. A sedimentation basin that is 452 feet long by 79 feet wide with an average water depth of 11 feet. And 8 filters, each 40.1 feet by 30.2 feet with an average water depth of 10.5 feet. The flow is 15.4 million gallons a day. So now we're going to pull our knowns and unknowns out of the word problem. So you have your 5 flock basins and their dimensions, your sedimentation basin and its dimensions, plus now we have 8 filters with their dimensions, and a flow rate of 15.4 million gallons a day. Unknown is the detention time. We just added another step, made this an even bigger problem. So your basins and your filters are all the rectangle or square, so we use the formula for rectangle, volume in gallons, length times width times height. And again, I went ahead and added the 7.48 gallons per cubic foot just to make this one smooth formula. Plug in all your numbers, 48 feet by 20.3 feet by 11.8 feet times 7.48 gallons per cubic foot. And there are 5 flocculation basins, so multiply by 5. Sedimentation basin of 452 feet by 79.9 feet by 11 feet by 7.48 gallons per cubic foot. And your filters, 40.1 foot by 30.2 foot by 10.5 foot times 7.48 gallons per cubic foot, and there are 8 filters, so multiply by 8. You get your total volume in gallons, your flock basin of 430,022 gallons, sedimentation basin of 2,971,526 gallons, and your filters 760,908 gallons. To get your total volume for your detention time, you add all 3 of those together. You get a total volume of 4,162,456 gallons. Again, we're looking for the flow rate in gallons per hour detention time. So convert 15.4 million gallons a day times a million divided by 24 hours in a day to get a flow rate of 641,667 gallons an hour. That's going to leave you with a detention time of 6.5 hours. Question number 5. Calculate the theoretical detention time in hours for a sedimentation basin that is 690 feet long, 48 feet wide, and has a water depth of 8.5 feet if the flow is 12.2 million gallons a day. So our knowns, the dimensions of the sedimentation basin, and 12.2 million gallons a day. We're looking for detention time. Sedimentation basin is a rectangle, so volume in gallons formula times the 7.48 gallons per cubic foot. Plug in your 690 feet by 48 feet by 8.5 feet times 7.48 gallons a cubic foot. It gives you a total volume of 2,105,770 gallons. Convert your million gallons a day to gallons an hour. 12.2 million gallons a day times a million divided by 24 hours in a day. 508,333 gallons an hour. Divide that into 2,105,770 gallons. You get a detention time of 4.14. Now note the theoretical detention time in this formula, pretty much solving for detention time in any flocculation basins and sedimentations is theoretical because the depths can vary just on the buildup of sludge on the bottom. So it is theoretical and not exact because you don't have exact measurements. Question number 6. Calculate the theoretical detention time in hours for a plant's flocculation and sedimentation basin if the flow is 8.9 million gallons a day. You have 5 flocculation basins, or 40 foot by 15 foot, and a depth of 12 foot, and you have 1 sedimentation basin at 400 foot by 60 foot and has a depth of 9 foot. So again, your knowns and unknowns, you have your 5 flock basins with the dimensions, sedimentation basin with its dimensions, and a flow of 8.9 million gallons a day. You're still looking for detention time. This time I'm going to solve it backwards because it's worded backwards in the problem. So we'll go ahead and do the gallons per hour first. So you're going to convert 8.9 million gallons a day times a million times 1 day is 24 hours. So you divide by 24 hours. That gives you an hourly flow rate of 370,833 gallons an hour. Next, we solve for volume using the same formula for volume. Rectangle, length times width times height times 7.48 gallons a cubic foot to get it in gallons. So you have your flock basin and your sedimentation basin. Flock basin is 40 feet by 15 feet by 12 feet by 7.48 gallons a cubic foot, and you have 5 flock basins. Sedimentation basin, 400 feet by 60 feet by 9 feet multiplied by 7.48 gallons a cubic foot. Means your flock basin is 269,280 gallons. Your sedimentation basin was 1,615,680 gallons. Add those together, get a total volume of 1,884,960 gallons divided by 370,833 gallons an hour. That gives you a detention time of 5.1 hours. Question number 7. Find the theoretical detention time in minutes for a clarifier that has a diameter of 120 feet and a water depth of 14 feet if the flow rate is 1.84 million gallons a day. So we find our knowns and unknowns out of our formula. The diameter was 120 feet, the depth was 14 feet, the flow rate of 1.84 million gallons a day. We're looking for detention time. So this is the volume of a cylinder, and it's given the diameter, so 0.785 times diameter squared times height times 7.48 gallons per cubic foot to get cubic feet into gallons for our formula. So 0.785 times 120 foot squared times 14 feet times 7.48 gallons a cubic foot. That gives us 1,183,755 gallons. We need to convert our flow rate from million gallons a day to gallons per minute. So if you notice that this question asks for detention time in minutes, so we've added the million gallons a day times a million times 1 day has 1,440 minutes. Put in your 1.84 million gallons a day times a million. You'll end up dividing by 1,440 minutes in a day. That gives you an answer of 1,278 gallons per minute. So just remember, when you're answering these questions, you need to answer them in the denominator it's asking for, and this one is asking for minutes. So the detention time is 926 minutes. Question number 8. Calculate the theoretical detention time in hours for the following treatment plant. It has a flow rate of 45 million gallons a day, a clear well with a 15 million gallon capacity, 4 flocculation basins measuring 60 by 10 by 10 feet each, a sedimentation basin measuring 350 feet by 80 feet by 12 feet, and 12 filters measuring by 40 feet by 30 feet by 15 feet. So the way this one's written down, it's already given us our knowns. Again, we're going to be looking for detention time. So I'm going to solve this one from top to bottom for each thing: flow rate, clear well, flocculator, sedimentations, and 12 filters. So we're going to convert the million gallons a day to gallons per hour. So 45 million gallons a day times a million divided by 24 hours in a day gives you 1,875,000 gallons per hour. We're going to convert the clear well million gallon capacity of 15 million to million gallons. So 15 million gallons times a million. This gives you 15 million to 15000,000. We solve for the floor flocculation basins. So 60 by 10 by 10 times 7.48 gallons a cubic foot times 4 basins. You get a total of 179,520 gallons. Solve for the sedimentation basin of 350 feet by 80 feet by 12 feet by 7.48 gallons a cubic foot. That's going to give you a total volume of 2,513,280 gallons. Now we're going to solve for the filters. So it's 40 feet by 30 feet by 15 feet by 7.48 gallons a cubic foot. And there are 12 filters. That gives you a total volume in the filters of 1,615,680 gallons. So we're going to solve for detention time. We're going to add the volume of your clear well, your flocculation basins, your sedimentation basins, and your filters together, which is going to give you 19,308,480 gallons divided by 1,875,000 gallons per hour. And before I go to the next slide, if anyone noticed, I put the improper thing for gallons because I put G, which is grams. Gallons per hour is actually going to be, gallons is GAL, not G. So for anyone that noticed, I did put G, which would be grams, but we'll fix that later. So we're going to do the math for this detention time. You get a detention time of 10.3 hours. Question number 9. Calculate the theoretical detention time in hours for the following treatment plant. It's got a flow rate of 33 million gallons a day, the 6 flocculation basins, 40 feet by 10 feet by 10 feet, sedimentation basin of 400 feet by 50 feet by 10 feet, 12 filters measuring 40 feet by 30 feet by 12 feet, and a clear well of 7.9 million gallons. Again, the way this is set up, I'm just going to use what they've given me already for my knowns, your unknowns, your detention time, and I'm going to solve for each. So we're going to convert our flow rate, 33 million gallons a day, times a million, divided by 24 hours, to give you 1,375,000 gallons per hour. 6 flocculation basins, so 40 feet by 10 feet by 10 feet by 7.48 gallons per cubic foot. There's 6 flocculation basins. They have a total volume of 179,520 gallons. The sedimentation basin is 400 feet by 50 feet by 10 feet by the 7.48 gallons a cubic foot to convert to gallons. The volume of that is 1,496,000 gallons. Solve for the 12 filters, 40 feet by 30 feet by 12 feet by 7.48 gallons a cubic foot. There's 12 of those. You get a volume of 1,292,544 gallons. We're also going to convert our clear well into a number for the formula. So 7.9 million gallons times a million, you get 7,900,000 gallons. So we're going to add all of our volumes together, and you get a total volume of 10,868,064 gallons. You're going to divide that by the flow in gallons per hour, so 1,375,000 gallons per hour. And that's going to give you a detention time of 7.9 hours. So that was a quick 9-question walkthrough. Um, Hopefully this helps you study like it helps me. Like, again, putting this all down PowerPoint and kind of going step by step. I have to repeat it and put it down. Like I said, hopefully it helps you because it's helping me. Thanks.